Alright, it's the second run through of my presentation. First time my audio was muted, so this might be a bit later than expected. I didn't realize until after after I uploaded it. Anyway, the title of my presentation, which is obviously the same as the title of the lab experiment, is visible spectroscopy lab, absorption of inks and lime cordials. My name is Noah Sor. Today's the 8th of November 2025, and obviously course was color chemistry, visible spectroscopy practical. Anyway, introduction. Obviously the purpose of my investigation was to investigate how the purpose of my experiment was to investigate how colored solutions absorb light at different wavelengths. I was also tasked to compare absorption spectra of different ink colors, as well as determining the concentration of an unknown lime cordial solution using absorbance data. The key concepts obviously here written below: the Beer-Lambert law. The color we see corresponds to the wavelength not wavelengths not absorbed, and absorbance concentration. Obviously, I got this from obviously some sources online as well as self-study, so I referenced them at the end of this presentation. Obviously here I have method and equipment. Unfortunately I was unable to take a picture of my equipment as I was doing the experiment, because I realized it too late after already having packed up, so I just wrote them down here anyways. So Spectrovis, obviously we use that. We use cuvettes, pipettes, test tubes, lime cordial and distilled water, as well as the ink samples of the following colors here listed below. Obviously the procedure was to summarize from the script we were provided by an instructor on the day of the experiment, as well as on Canvas. So these are just obviously summarized, because the lab script there is in much more details. But obviously to begin, I calibrated the spectrometer with water, measured the absorption spectra of each ink sample of the following colors. Then we obviously prepared the following cordial solutions, as well as recorded the absorbance peaks and the wavelengths, measured the absorbance of an unknown sample, and then we used the calibration curve to find the concentration. Obviously these are my results from the ink samples, as you can see, of the following colors which I listed in the previous slide. You can see obviously here the wavelengths, they vary. However, blue and green, they were quite similar, so I'm not too sure if that's based off I'm not too sure what error we made, but obviously that is based off an error on our part, most likely, or maybe that is the correct results. But I was more certain, as we did the investigation, that there was an error on our part, obviously. So I just wrote that down. But I also checked with some of our classmates. Me and my partner checked with some of the classmates, and this was the general consensus around. People got very similar answers, so I just thought ours were too similar. Anyway, you can see absorbance peaks and wavelengths, they vary. Blue had obviously absorption peak of just 1. Black had the obviously the highest absorbance peak as expected, as well as blue and green had the highest wavelengths. Obviously one of these is less likely to actually be true. The visible spectroscopy results for the lime cordial solutions, obviously the pattern is as the concentration increases, the absorbance peaks increases. However, the unknown, there was slightly less. Again, we weren't sure how accurate this result was, but the general consensus around the room was again it lined up, so we stuck with it. Obviously now you can see the wavelengths here, they vary, but the general pattern is it starts to go up until we reach 60%, and then it goes down slightly, obviously, then it carries on going up, and then the 100% one again goes down. So we were a bit worried about the 60 and 100% concentration, but otherwise I think this part of the practical also went quite solid. Just again, errors which I wrote down again in slides to come, that there definitely were some errors there on our part. Obviously 100% success rate is never assured. And observations here. Obviously, absorbance increases with concentration, confirms the Beer-Lambert law. Obviously, there was a small variation around 390 to 396 nanometers, which obviously may be due to instrumental or measurement errors. Obviously, the ink showed distinct absorption peak corresponding to complementary colors. So, like I said, some of the results were expected based on the colors we had. And again, like I mentioned, black absorbs broadly across the visible range. So I wasn't too shocked with the results we got for black. I think those were pretty accurate. Obviously, like I mentioned throughout this whole slide, there were errors. And obviously, we spoke to our instructor, and obviously, they were most likely due to residue in the cuvettes or bubbles. We were tasked to keep tapping the cuvettes on the table to get rid of the bubbles. Sometimes there were such small bubbles which we were unable to get rid of, even after trying again and again. So we just had to stick with it and hope they didn't affect our results too much. Obviously, that may not have been the case. They might have affected them in some capacity. Obviously, slight miscalibration as well. To begin the experiment, we calibrated with water, but obviously we could never be certain if we did it right. Obviously, again, fingerprints or smudges could come. We constantly use blue rolls to wipe the cuvettes, making sure there were no fingerprints, but you can never be too certain. Somehow, fingerprints get in if I put them in or take them out, and we tried again and forget to wipe it, obviously. And then obviously the most obvious human error is using pipette, or could have also been measuring cylinder. But using pipette there, it's never 100% accurate that you get the exact amount of solution that you actually need, because obviously it's never 100% with a pipette. There could always be error with, even if it's plus or minus 0.5 of a centimeter cubed or whatever it was. Obviously, here I have my calibration curve and absorbance versus concentration of the lime cordial. The unknown was around 65%. So I just put an X there. We used the website to create the graph, and then the X I just used it. I just made it in a Google Doc, and then I screenshotted that and put it on here, this Google slide. But yeah, I think obviously you can see the general pattern is as concentration increases, absorbance increases as well. Obviously, like 40 and 50% again, the results were quite similar, but there's nothing to worry about, because obviously we can see that it does go up slightly, 50%, and then it carries on going a significant steady and steep slope. So I was quite happy with these results. And then to finish, obviously, my references, I just had to make sure I didn't plagiarize or anything, so I just mentioned my references here below. Obviously, the visible spectroscopy lab script provided by instructor. Steve was our instructor, so I think it's obviously obvious. The rubric and presentation guidelines, and then obviously I used the Beer-Lambert law, standardized theory reference. I just found that online and just found it very useful, so I just made sure to reference that below as well, just in case. Anyway, this brings me to the end of my presentation. I know this is probably uploaded late because I have to make sure this time I align the audio properly with the video, and it takes me time as well because I have a poster deadline on the same day, 10th of November. So I just hope I get this done in time. Anyway, thank you very much for listening, and that brings me to the end of my presentation. Thank you.